Alright class, so it's session number 10, exercise 15.2 and it's week 2. In today's class we are going to start from question number 4. In the last class we had discussed about the differentiation and how you find the differentiation which includes power. Alright, so for the first part the question says it's 2 minus under root x to the power 6. When I derivate it, first I need to write down the power, so it's 6. Then I need to subtract 1 from the power, so that will be 6 minus 1 leads to 5, and then we need to find out the derivative of a function. The derivative of a function, the derivative of 2 is 0. You need to find out the derivative of root x. So if I say d by dx of root x, that will be, first you need to write down the power and then subtract 1 from the power. Alright, so that is the derivative of root x. So it will be minus 1 upon 2, x to the power minus 1 upon 2. 2 1s are 2, 2 3s are 6, so the final answer it will be 3. 2 minus under root x to the power 5 divided by x to the power root, and the minus sign is also present, so that is the first part answer. Alright, so moving on to the next one, it's part B. It says 1 divided by 1 minus 1 upon x to the power cube. Now first, before differentiation, I need to arrange my equations. That will be equals to 1 minus 1 upon x to the power minus 3. When you shift positive 3 in the numerator, power changes its sign. Now we can derivate it. So first we need to write down the power, then subtract 1 from the power, so it will be minus 4, and the derivative of 1 upon x. Now if I need to find out the derivative of 1 upon x, basically that is equals to d by dx of x to the power minus 1, right? And that derivative equals to minus x to the power minus 2. So that is the derivative of 1 upon x, and I will use this one here. So it is equals to minus 1 upon x is equals to minus x power minus 2. Alright, so now it will be minus 3 1 minus 1 upon x power negative 4 multiplied with x power minus 2. Or if I arrange it more further, so that will be minus 3 divided by x square times 1 minus 1 upon x to the power 4. That is your answer. Alright, so first you need to write down these two solutions in your copy, and for these two questions you have a time of 90 seconds to write down these two solutions in your copy, and then you will start the next one. So start. Alright, so moving on to the next one, what you need to do, you have a homework question, it's part C. Alright, that is your homework, and I will begin with the part E. The question says x minus 1 upon x to the power whole cube. Now it's up to your choice, either you can take LCM here or start in this same way. So if I start in the same way, first I need to write down the power 3, subtract 1 from the power, so 3 minus 1 leads to 2. Now I need to find out the derivative of this function. So d by dx of x is 1 minus d by dx of 1 upon x is x power minus 2, so its derivative is already found out. The final answer it will be 3x minus 1 upon x whole square, 1 minus minus plus. Since the power of x is minus 2, so I can write it 1 upon x square. To make the power positive, I shift it in the denominator. Alright, so moving on to the next one. It's question number 5. Alright. The procedure is same, that you need to find dy by dx of the following equations, and we had done similar type of question in the previous question as well. But in this question, the differentiation which has power on it, this is the main difference between this and the last previous question, in which we have the given values, and you need to assign those values to find out the exact value of dy by dx. So for first part, the question is y is equals to 3x minus 1 to the power 4 at x equals to 1. We need to find out the gradient, that means dy by dx. So if we are going to start differentiation, so dy by dx equals to, the derivative of the function is, first you need to write down the power, then subtract 1 from the power, so 4 minus 1 leads to 3, and then the function which has power, so the derivative of 3x leads to 3. So if I arrange it, so that will be 12 and 3x minus 1 power cube. Now I need to assign the value of x, so I will say that dy by dx at x equals to 1 equals to 12, 3 ones are 3 minus 1 and whole cube equals to 12, 3 minus 1 it's 2 and 2 cube, that will be 12 multiplied by 8 leads to 96. That is your first answer. So you need to write down the solution in your copy, and for that part you have a time of 60 seconds to start. After the first part, I will start with part D. Alright, so it's y is equals to 4x minus 5 to the power cube, and y is 27. At first we need to find out the value of x here, so I'm using y here, so y is 27 equals to 4x minus 5 to the power cube. In order to eliminate cube, we need to apply cube root on both sides. Alright, and the benefit of cube root is it cancels the power cube on the right side. So on the right side we have 4x minus 5, and the cube of 27 leads to 3. So I can find out the value of x now. So minus 5, when you shift it, it will be plus 5, and it's 8 equals to 4x, x equals to 2. Once you got the value of x, now we can start the differentiation. So y is 4x minus 5 to the power cube. Start differentiation, dy by dx is equals to first power, then subtract 1 from power, and then the function which has power on it, we need to find the derivative. So 3 4s are 12 times 4x minus 5 whole square. I need to place the value of x, that is 2, we had find out. So it's 12, 4 2s are 8 minus 5 whole square equals to 12. 8 minus 5 is 3, 3 the square is 9, and 9 times 12 leads to 108. That is the value of dy by dx at x is equals to 2. That is the final answer. Alright, so you need to write down the solution in your copy first, and for that part you have a time of 60 seconds. Try to maintain your lecture copy from the beginning of this session. Alright, so give it a try, start doing it by on your copy. and then I will start the next question. So start. All right. So what you need to do, you need to attempt part P as your homework. All right. Moving on to the next question. It's question number 7. Now, it says that calculate the coordinates of the point. First, we must understand what do you mean by coordinates of the point. It means the value of x and y both. Mostly students just write down the answer of x and think that it is the final answer, but it is not. If it asks about the coordinates, then you must highlight the value of x and y. Calculate the coordinates of the point on the curve y equal to this, at which dy by dx equal to 0. Now the given condition is gradient is 0, alright? So what you need to do, you need to try it by yourself first. I'm just explaining you right here. First you need to find the derivative of this function. Once you got the derivative, you need to equate the derivative with 0 and find out the value of x, alright? So give it a try. You have a time of 90 seconds and then I will start, so begin. Alright, the equation of the curve we have is y equals to under root x square minus 2x plus 5. And instead of under root, I can say that the power is 1 divided by 2, right? Now we can start the differentiation. So dy by dx is equals to, first we need to write down the power 1 upon 2 x square minus 2x plus 5. Then we need to remove 1 from the power, so 1 upon 2 minus 1 leads to minus 1 upon 2, and then we need to find the derivative of the function which has power. So derivative of x square is 2x, derivative of minus 2x leads to minus 2, alright? That is the complete differentiation of the function. Now it says that the value of dy by dx we have is 0 is equals to 1 upon 2. The power we have is minus 1 upon 2. When I shift it in the denominator, it's x square minus 2x plus 5 with the power of 1 upon 2, and in the numerator we have 2x minus 2. So far so good. Alright. Now if I shift the denominator on the left side, so 0 multiplies with the denominator, make it 0. So 0 equals to 2x minus 2, 2x equals to 2, and x is equals to 1. That is the coordinate of x. but not the final answer because we don't know the value of y. For y, we are using this equation y equals to x square minus 2x plus 5 with the power of 1 upon 2. The value of x is 1, so at x is equals to 1, y equals to x is 1 minus 2 plus 5 with the power of 1 upon 2. So 1 minus 2 leads to minus 1. Minus 1 plus 5, it's 4 power 1 upon 2. So y is 2. So the final answer of the coordinates are 1, comma 2. That is your final answer. Alright, so I hope that it is clear to you, because in the previous classes we have invested sufficient amount of time for the basics of differentiation, right? So now we are just applying all the concepts we have discussed in the last couple of classes. Moving on to the next one. The curve y equals to a minus x power 3 has gradient minus 1 upon 3 at x equal to 2. Find the possible values of a. So you need to give it a try by yourself first, but let me explain you what you need to do. First, we need to differentiate this equation, right? On your differentiated equation, when you place x equal to 2, so you need to place dy by dx with minus 1 upon 3. Alright? By equating the equation, you can easily find out the value of a. So first, give it a try by yourself. Time for this question is 2 minutes. Alright? Take your time, start doing it, and then I will explain, so start. Alright, we have the equation y equals to a minus x power q. Alright, first I'm going to start the differentiation. Dy by dx is equals to, first we need to write down the power, then subtract 1 from the power, and then the function which has power. The function which has power is a minus x. The derivative of a is 0 because it is a constant, but the derivative of minus x is minus 1. Alright, now it will be minus 3 times a minus x whole square equals to dy by dx. That is for the differentiation. Now I'm going to use this condition. Alright, so I will say that dy by dx at x is equals to 2 is equals to minus 3 a minus 2 whole square, and the value of gradient when x is 2 is minus 1 upon 3. So instead of dy by dx, I am going to use minus 1 upon 3 equals to minus 3 and a minus 2 whole square. Now you can solve the equation it's minus 1 upon 3 equals to minus 3 a minus 2 whole square. On both side we have negative sign, so it cancels. Here we have 3 multiplication with a minus 2, so on the left side it will be 1 upon 3 3s are 9 equals to a minus 2 whole square. To eliminate the square we need to apply root on both sides, so now it will be a minus 2 equals to 1 upon 3. But since there is no such conditions regarding the positive and negative values, and also in the question it says that find the possible values of a, so now we need to introduce plus and minus sign with the after the under root. So firstly, if I consider the positive sign, I will say that a minus 2 equals to 1 upon 3. For the negative one, a minus 2 equals to minus 1 upon 3. So a equals to 1 upon 3 plus 2. A equals to minus 1 upon 3 plus 2. A equals to 3 to the 6 plus 1 7 upon 2. A equals to 3 to the 6, 6 minus 1 is 5 divided by 3. Alright, here we have 7 upon 3. So these are the two values of A. Alright, so I hope that this question is clear to you and the concept are almost same, that how we are differentiating the equation. First we need to write down the power, then subtract 1 from the power, and then differentiate the function which has power on it. These are the three basic rules that we are discussing from the beginning of this chapter. Alright, moving on to the next one. It's question number 9. Find dy by dx and calculate the gradient of the tangent to the curve y equal to x square minus 2x minus 4 whole power cube at the point where x equals to minus 1. Now that is a very traditional question we have attempted many times in this class and the last class as well. So what you need to do, you need to give it a try by yourself, and time for the first part is 3 minutes. Alright, so take your time, but make sure that you are doing it on the right path for start. Alright, for first part, the question is y equals to x square minus 2x minus 4 with the power 3. First we need to start the differentiation. So dy by dx is equals to, first we need to write down the power, alright, then subtract 1 from the power, so 3 minus 1 leads to 2, and then we need to derivate the function. The differentiation of that function is x square is 2x minus 2x derivative is 2, alright. So we have differentiated the function. Now we need to apply the value of x. So dy by dx at x equals to minus 1 equals to 3. Instead of x, I am going to apply minus 1. So minus 1 square minus 2 minus 1 minus 4 with the power of 2 and 2 minus 1 minus 2. Alright, now we can solve it. So 3 minus 1 square is 1, minus minus plus 2 minus 4 square, it will be minus 2 and minus 2, so it's 3. 1 plus 2, 3, 3 minus 4 minus 1 square is 1, minus 2 minus 4, the final answer is minus 12, that is derivative of the function at x equals to minus 1, and that is your final answer. Alright, I hope that the first part is clear to you, and for the second part it says that y equals to 1 divided by under root 1 plus x at the point where x equals to 3. So first thing, whenever you have such root type questions, you need to shift the denominator in the numerator. So now it will be 1 plus x with the power of minus 1 upon 2 equals to 1. Alright, now I expect that you can easily solve the question. So now the time for this part is 2 minutes. So give it a try and then I will explain. So start. Alright, so when you are going to find out the derivative of the function, it's dy by dx equals to, first we need to write down the power minus 1 upon 2, then subtract 1 from the power, so minus 1 upon 2 minus 1 leads to minus 3 upon 2, and then the function which has derivative, so that will be 1 only. D by dx of x is 1, d by dx of 1, that is constant, leads to 0. So now it's minus 1 divided by 2, and I shift the numerator in the denominator, so its power will be positive 3 divided by 2. Alright, that is a function of dy by dx. Now we need to substitute the value here. So dy by dx at x equals to 3 equals to 1 divided by, sorry, minus 1 divided by 2, 1 plus the value of x we have is 3 and whole power is 3 divided by 2. Now you need to solve it. So minus 1 divided by 2, 1 plus 3 is 4, and instead of 4 if I write 2 square, that will be same, right? 3 divided by 2. And the reason why I write 2 square here, this 2 and this 2 can cancel. The leftover part is minus 1 divided by 2 multiplied with 2 power cube. So minus 1 divided by 2 cube is 8 and 8 2s are 16. That is the answer for dy by dx at x equals to 3. Alright, now moving on to the next question, that will be the last question of today's class and last question of this lecture as well. It says that given that f of x is 1 plus under root x with total root where x should be greater than or equal to 0, show that f prime. Now what do you mean by f prime of x? It is equals to dy by dx. It equals to 1 divided by 4 under root x plus x and under root x. Now that is a prove that question. So firstly, what is f of x? It's y equals to under root of 1 plus under root x. So there are two methods that we can differentiate it. At first I will go with the traditional method, but before that, for your easiness, what I will do, I will find the differentiation of root x separately. So that will be 1 upon 2 and separate 1, so that is minus 1 upon 2, and it leads to 1 upon 2 under root x. Now that is a differentiation of root x. Alright, we are going to use that differentiation in our solution. So at first, y is under root 1 plus root x. We know the first step very well. In order to derivate the function, first we need to write down the power, then subtract 1 from the power, and then we need to derivate the function which has power. So the function which has power is 1 plus root x. Alright, now here you have negative power. If you shift the power in the denominator, so that will be 1 divided by 2 under root 1 plus under root x. For that part, differentiation of 1 is 0, and differentiation of root x we had already find out that it is equals to 1 upon 2 under root x. Alright, now simply we need to multiply these two brackets, so that will be 1 divided by 2, 2s are 4. Alright, it will be under root of 1 plus under root x times under root x. Alright, and after that we need to multiply these two brackets. So let's suppose if I write in this form 4 divided by 1 divided by 4, this root x is basically x power 1 upon 2, right? And we have 1 plus x power 1 upon 2 with the total power of 1 upon 2, right? Now the power of these two are same, or in general what I'm saying that if you have root 5 times root 3, so that is root 15, right? These two can be multiplied with the presence of root sign. So now it will be as same 1 divided by 4. This x multiply with 1, so it's x, right? This x 1 upon 2 multiply with this x 1 upon 2, right? Now here it will be plus x, this x multiplied by this one, root x, and total root is present. That 1 upon 2 is basically that total root is present. So that is your dy by dx, and that is, I think we need to show that 4 under root x plus x root x. Yes, so that is your final answer. Alright, so I hope that all of you are now clear with this question. So you need to write down the solution in your copy, and for that part you have a time of 2 minutes. First try to attempt it by yourself, and where at any point where you stuck, you can see the solution. Alright, so start. All right. So that is the end of today's class. But as a homework, one more question. You need to attempt question number 6 of the same exercise 15.2. Inshallah, next class we have to continue the new exercise 15.3. Till then, take care and Allah Hafiz.